Hello everyone, this is problem 21, which has three vectors that we need to add. Now remember that addition of vectors is different from addition of numbers. We cannot go and add 50 plus 40 plus 60 and write the answer as 140 meter per second. This would not work. The way vectors are added is by placing them tail to tip. I'll start here by showing the graphical method of adding vectors, which is not required in this course, but it will give you a good estimate of the magnitude and the direction of the resultant vectors. To add vectors graphically, we place them tip to tail, meaning we'll move the second vector so that its tail is placed on the tip of the first vector, and we'll do the same thing for the third vector. It doesn't matter which vector you start with, meaning if you add vector 1 to 2 to 3, it will be the same outcome as adding vector 3 to 1 to 2 and so on. So here vector 2, for example, if we move it from this position to this position, and we can move vectors as long as we are keeping the same magnitude and direction. So vector 2 will be somewhere here, and again I'm just doing a rough drawing. So this is vector 1, which is the 50, this is vector 2, which is the 40. I moved it from this position to this position. Then the same thing here for vector 3, place it here, trying to keep the same length, which is magnitude, the same magnitude and the same direction. So this will be kind of vector 1, vector 2, vector 3, and the resultant vector, which is the vector that represents the sum of the three vectors, will be the vector that connects the tail of the first vector to the tip of the last vector. So this is the tail of the first vector. I'll connect it to the tip of the third vector. So somewhere here, kind of estimate of the length and the direction of the resultant vector. We expect that the resultant vector will be kind of smaller than any of the three vectors, and also its direction is in the third quadrant, somewhere in the third quadrant, kind of somewhere between 60 and maybe 90 degrees here in the third quadrant. So this will give us rough estimate about the magnitude and direction of the vector. So if our answer came out something like 80 or 90 meter per second, we know that we did something wrong, because according to this graphical method, the vector is smaller than any of the individual vectors. And also if we get it somewhere at an angle of, let's say the angle came out to be in the second or first quadrant, then we know we did something wrong. So this is just to verify our results. But again, you don't have to do this step. This is just kind of a way to predict what we expect. We are going to use a method called resolving into component method, which is basically resolving the vectors into components and then adding the x component. The sum of the x components will be the x component of the resultant vector. And we'll do the same thing for the y component. And then when we get the x and the y component of the resultant vector, we'll be able to tell which quadrant it is in, and also we'll be able to find the magnitude of the resultant vector by applying the Pythagorean theorem. So let's apply that. Okay, we can start by creating a table. In the first column, we'll include each vector's magnitude and direction. In the second column, we'll resolve each vector into its x component, and in the third column we'll resolve each vector into its y component. In the last column here, this will be the sum of the three vectors. So we'll get the x component of the resultant vector and the y component of the resultant vector, components. Now the first vector is this vector here, it's 50 meter per second, and you can see it's lined up with the positive x direction, so it has 0 angle. So vector 1 here is 50 meter per second at an angle of 0 degrees. The second vector here is the 40 meter per second, and we can see here that it's in the third quadrant. We need to write the angle as a standard angle. We are given the related angle to be 40 degrees, and we know when the vector is in the second quadrant, the standard angle will be 180 minus 40, because it's from this point to this point is the standard angle for the second vector. We know from here all the way to the negative x is 180, so this angle will be 180 minus 40, which will give us 140 degrees. So this will be at an angle of 140 degrees with respect to the positive x-axis. The third vector is 60 meters per second, and and it's at an angle of 180 plus 70 because it's in the third quadrant. The 60 meter per second is in the third quadrant. So we have to add 180 to the related angle. So 70 plus 180 will give you 250 degrees. So now we wrote the three vectors in the format of magnitude and direction. We'll go ahead and find the x component of each vector. Now for the 50 meter per second, the x component is 50 because the whole vector is an x component. It does not have a y component. The y component will be 0. So it's 50 meter per second, and this, of course, in the positive x direction. Y component is 0. And we can do the calculation here. You'll take 50 sine 0. 50 sine 0 will give you 0. While 50 cosine 0 for the x component, it will be 50 cosine 0. Cosine 0 is 1. So 50 times 1 will give you 50. For vector number 2, it will be 40 meter per second times cosine 140. Cosine 140 will give you negative 0.766. So the answer here will be negative 0.766 times 40, which will yield minus 30.64 meter per second. So that's the x component of the second vector. The y component of the second vector will be 40 meter per second times sine the angle 140. Sine 140 will give you positive 0.643. When you multiply it by 40, this will yield 25.71 meter per second. And notice here this is positive, while the x component is negative. And we expect that because the second vector, as you see here, is located in the second quadrant. So its projection on the x-axis will give you a negative vector, while its projection on the y-axis will give you a positive vector because it will project in the positive y-axis. Now we'll do the same thing with the third vector. We'll find the x component by multiplying the magnitude of the vector by cosine the standard angle. So 60 cosine 250, which will yield negative 20.52. Cosine 250 will give you a negative 0.342. And again, guys, make sure that you set the calculator at the degree mode, not the radian mode. While the y component will be 60 meter per second sine the angle. Sine 250 will yield negative 0.940. When you multiply it by 60, this will yield negative 30.76. When you multiply it by 60, this will yield negative 56.38 meter per second. Notice here that the x component and the y component of the third vector are negative values. And we expect that because the third vector, as you see here, is in the third quadrant. So its x component will be in the negative x direction, and its y component will be in the negative y direction. Okay, since we have the x components of the three vectors and the y components of the three vectors, we'll go ahead and add them so that we get the x component of the resultant vector and the y component of the resultant vector. So now we are calculating the x component of the resultant vector. Let's call it rx, and this is ry. And now we'll add 50 to negative 30.64 to negative 20.52, and this will yield negative 1.16 meter per second. While the y component of the resultant vector will be negative 30.67 when you add the 25 to the negative 56. Notice here that we got negative value for the x component of the resultant vector and negative value of the y component. What does that tell us? This tells us that the vector is in the third quadrant, because in the third quadrant, the y component and the x component are negatives. You need to know that very well. In the first quadrant, the x and the y component are positive. In the second quadrant, the x component is negative, while the y component is positive. In the third quadrant, both x and y components are negatives, and in the fourth quadrant the x component is positive while the y component is negative. So this is how you can tell in which quadrant the resultant vector is located, and this is very important in solving such problem. So now we can go ahead and calculate the direction of the vector and the magnitude of the vector. Let's start, for example, with the magnitude. the magnitude of the resultant vector, and we'll put it in absolute value, which indicates it's a magnitude, is equal to the square root of the sum of the square of the x component added to the y component. So this will be the square root of the negative 1.16 meter per second square, and of course when we square it, the negative will disappear, plus negative 30.67 squared. And I'll let you carry out the calculation here. So make sure you complete the calculation, make sure to add correctly. So this will enable us to get the magnitude of the resultant vector. Now, magnitude is not enough, we have to find the direction. So for the direction, we'll start first by finding the related angle of the resultant vector. So it will be the tangent inverse, as we learned, of the y component over the x component, and this will yield tangent inverse. And again, you don't have to include the signs, but anyway, if we included the signs anyway, they will cancel out, the negative will cancel out, but it will be 30.67, that's the y component, the negative 30.67 over the x component, which is negative 1.16 meter per second over meter per second. Of course, the units will cancel out, and the related angle will come out to be 87.83. So it's in the third quadrant and it's making an angle of 87.83 degrees. So this is the related angle. We need to find the standard angle, and we know to find the standard angle we have to add 180 to the 87.83 since it's in the third quadrant. So theta, which is the standard angle, 180 degrees plus 87.83, and this will give us 267.83 degrees for the standard angle. So now we have the magnitude of the vector and we have the direction using the standard angle. So now we can write the vector quantity of the resultant, which will be whatever the magnitude here at this angle, which is 267.83 degrees, and this will be the answer here. And you can see we found that the vector is in the third quadrant as we expected when we did the graphical method. Alright, I hope you found this video educational. Thank you.